Chapter 21, Assess Continued. This is question 7. Copy the table of values. No, I'm just going to work them out and shove it in there. For the cubic function y equals x cubed minus 3x minus 2, for all the values of x from minus 4 to 4. So here we go. I had to work out 1, 2, 3, 4, 5, 6 of these things. Not very difficult. As is usual, I took my minus 4, planted it in the position where the x was, and got on with it. So minus 4 cubed, minus 64, and minus 3 times minus 4, because the x is minus 4. Minus 3 times minus 4 is plus 12. Then take away the 2, because that's what it says you've got to do. So we've got minus 54 altogether. So therefore my y value is minus 54 when my x value is minus 4. So I've done that and I've planted it in the table appropriately. Did the same for the others as well, and they're all correct. So I've done that, and then it says draw the graph of x cubed minus 3x minus 2, and bam, there she is. I think she's absolutely lovely. Y equals x cubed minus 3x minus 2, I believe. Is that right? Yeah, got it. And I just appreciate the shape. It's a standard up, down, up curve. It's a classic x cubed arrangement. It's beautiful. Now let's answer one or two questions. Use your graph to solve the following equations. Where the graph equals 0, in other words, where it cuts through the line, y equals 0. So let's just do that quickly. Where is y equal to 0? Here on the x-axis. So there's y equals 0. So I've got a solution. Oh, it's very, very hard to see. There and there. Yep, just two solutions only. I know I've sort of gone up above the hump and then back down again, but really it's only going to cross in this one position here. So we're touching the minus 1, climbing down, then touching the 2. So let me just check from my graph table. Yeah, look, when y equals 0, there and there, I've got two solutions, minus 1 and 2. So it's there in black and white, isn't it? So x equals minus 1 and x equals 2. Again, had I not got, I shouldn't have gone above that, but that's how I remember. I'm drawing this freehand. It's really hard. So there, one solution there and one solution there, no more. Now what? Right. So I've got y equals x cubed minus 3x minus 2 and y equals 20. So I've got to draw on the line y equals 20. Here I go. So just draw it in red so it stands out nicely. Y equals 20 right there. Whack it across and label it. Y equals 20. Just one solution. Oh well, after all that aggravation, right there. Draw it in. So I'm reading straight down there. I'm going to make that 1.2 or 3. Who knows? 2 squares. Let's go for, well, it's not 1 point, whatever. It's 3.2, should we say? Yeah. So 3.2. One solution only. So x equals 3.2. And the last one. Y equals x cubed minus 3x minus 2 equals minus 30. So I'm looking for the graph of y equals minus 30 to draw in. Again, one solution just there. Minus 30, let's whack it over here. So, oops, not very good. Start about here. Oh, it's not brilliant, that'll do. Go on. So that's y equals minus 30. One solution. We'll read it up right now and see what we get. Try and keep it nice and straight and honest. Reading straight up. 1, 2, 3. I'm going to call that minus 3.3. That's what I get. So x equals minus 3.3. There's my solutions to that lovely, lovely question. There's the graph. It's beautiful. And here's another great question. This is on page 326, A star. Again, matching graphs with their functions. Alright, so let's look at them. I've got y equals minus 2 to the power of x, so it's a power graph. I've got y equals minus 5 over x, so it's a 1 over x type graph. In other words, a reciprocal graph. I've got y equals cosine 3x, so it's basically a cos x type graph involving waves up and down. And I've got y equals 2x cubed, basically a cubic function. Well, let's just do it the easy ones first. Well, look at that one. Y equals 2x cubed. Here's a classic cubic function right there. Up, a little kink, and up again. So I'm going to go for this one. It's going to be y equals 2 x cubed, and there isn't a single one like it anywhere on the page, so C goes with graph D. So let's just put a D there, and there's our answer. Now let's look very carefully at this one. There's only one that looks all squiggly like that, and that's that one down here. And as you can see, if this was y equals cos x, then that will be the 0.01, etc. Alright, but if it's cos 3x, we're getting 3 times as many waves in the space that we get normally for the graph of y equals cos x. So this is the one, y equals cosine of 3x. It doesn't matter if you don't understand what 3x or 2x or 6x is. It's that particular characteristic graph, this wavy type thing that repeats itself. So that's the graph of y equals cos 3x, and so question B goes with graph C. Now we've got 2 left, and they're both strange. I want to tackle this one because it's easier. If it was a graph of a 1 over x type graph, it'll look like this, wouldn't it? A branch there and a branch about here. That's not the case. I've got a branch in the 2 different sections, 2 different quadrants of the graph. So it's a reciprocal graph that's been inversed. It's a reciprocal graph rather that is negative. Therefore, this branch appears over here, and this branch appears over here, and this branch appears over here. So that's what we've got. And it's still a 1 over x type graph, but it's negative. Y equals minus 5 over x, and that is graph B, which leaves us D with graph A. But that's not good enough. Let's explain it, shall we? Y equals minus 2 to the power of x. Now look, if it was just 2 to the power of x, it'll do something. In fact, let me just get this out of the way because I want to draw it. If it was 2 to the power of x, you know it's going to look something like that. Just take off and take off and take off and take off like that. But look, it's the graph of y equals minus 2 to the power of x. In other words, it's a reflection in the x-axis, and that's how these minus power graphs look. Alright, so graph in question D matches function A, y equals minus 2 to the power of x. Alright, so that's y equals 2 to the power of x, for example. That's how it would look. And y equals minus 2 to the power of x will look a little bit like this. So that's what we've got. We've matched the correct function with the correct graph, and that's it. End of the assess, end of these difficult functions, some of them very interesting shapes, and I'll now prep chapter 22.